Hello students, welcome to Showups Sir classes. So we are solving the mathematics paper from JAM 2023 and this is question number 35. Let us see the question. Which of the following functions is slash r are remain integrable in the closed interval 0, 1? So the four options are given. So what we will do, we will check this one by one, right? So let us check with the option number A. So it is given that fx, we have this in the integral 0 to x mod of half minus t dt, right? Now here we have this, if we remove the mod function from here, so it can be written as that fx can be written as integral of 0 to x, we have this half minus t dt when t is less than equal to half, and we can write that 0 to x minus of minus half minus t dt when t is greater than half, right? So if we integrate these two functions for t less than equal to half and for t greater than into half, what we will get, let us write this integral in a proper manner. So for the first case, what will happen? So we will have this minus of minus of half minus t whole square by 2, and this should be 0 to x for t less than equal to half, and so that is going to be fx, and this should be half minus t whole square by 2 from 0 to x, that we have t is greater than half. Okay. Now if we simplify this and if we solve it, the integral value with the 0 and x value, so what we will get, so we will be getting over there, and let's solve this simple thing. So we will have, for the first, it will be minus of half minus x whole square minus half minus 0 whole square, this, and this will be the second one. The function will be half minus x whole square minus of half minus 0, right? Now your fx after solving this will be minus half, so this will be your half minus x whole square, this is 1 upon 4 for x less than equal to half, right? And this would be half of half minus x to the power whole square by minus of 1 upon 4 for x greater than half. So how it is happening over here, since we have the range or a range of t lies within this 0 to x, and t is greater than half for the first case, similarly, so we should have x should be less than equal to half. Similarly, for the second function, x is greater than half for t greater than half. Okay. Now we have to see that in these 2 points, this half and minus half, you have to find the, if there is any point of discontinuity is there. So to find that if it is continuous, so we have to find first the at x equal to half, we should find the limit, left hand limit. So it should be equal to, this is limit x tends to half minus, right? So what should be the value if x tends to half minus? So we have minus of half, here it will be, so half minus half, it's 0, whole square means 0 minus of 1/4, so it is 1/8. So this is the left hand limit. Similarly for the right hand limit, so we would have this limit x tends to half plus, so we have, this is half, again for x greater than half, this half plus, so it will be minus half, right? So this will be, again it will be 0, so 0 minus 1/4, we have minus 1/8. And what will be the function of this if we write this at, what is the value of f, the function at f half? If you solve it, it will be 1/8. So though the left hand limit is equal to the f at half, but it is not equal to with this right hand limit. So this function fx has a discontinuity at half, and since this is a finite discontinuity, there is only one discontinuity at half, so this a is Riemann integral, right? Now for the option B, that where fx is x of sine 1/x for x not equal to 0 and 0 for x equal to 0, what we can write? So for the option B here, let us take that fx is a continuous function, okay, and we have for x not equal to 0 this value x of sine of 1x. So if fx is continuous, then limit x tends to 0 fx, we can write this as limit x tends to 0 x of sine 1/x, where the range of sine x is from -1 to +1. Since it is given, you can see that at, if x is equal to 0, then it is 0. So if it is a continuous function, then this term fx should be equal to 0 for x equal to 0, right? Now we can see that sine x is a bounded function, the sine of 1 by x, right? So sine of 1 by x is a bounded function. Since the function is continuous at x equal to 0 and the value is 0, so suppose we put this x, the value of x is over here, if we put the limit, so it is 0. So anything, this x when x equal to 0, 0 multiplied by a bounded function is, should be a bounded function and it should be equal to 0, right? So I can see that the x of sine 1 by x is also continuous. So option B is also, this particular function is also Riemann integral, right? Now see, option C is given that fx is equal to 1 to -1. 1 will be in the, when x belongs to the, this set of rational numbers, this in the intersection of 0 to 1, and otherwise it is -1. So let us see it pictorially for option C. So we have this fx function. Suppose this is the y equal to fx. and we have x over here. So 0 to 1 in this range, so this is 0, suppose this is 1. What it is given over here? Let's see the option. That for the set of rational numbers in this interval, closed interval 0 and 1, that there should exist at least 2 rational numbers, and otherwise in the same interval it is an irrational number. So if we take this interval, suppose here is our rational number, here is our another rational number, and let us take this as an irrational number. If this is the scenario, so for the rational number, it is the value is 1 on the y-axis. So if we take this value as 1, so this is the value, and if we take it as minus 1, so this is the value for the complementary function, or in the case of otherwise. Again, for this rational number, the value is at 1. So we can see that the points are discontinuous, right? So this point are discontinuous. Let's write it better. This discontinuous points, right? So here in between these points, this range over here from so what will happen, the scenario will be like that. We will get an infinite number of discontinuity. If we have a finite discontinuity, then you can say it is a Riemann integrable, right? A finite number of discontinuity. But for a infinite number of discontinuity, it is not a Riemann integrable. So this option is incorrect. Option C is incorrect. Right. Now let us move to the option D, the last one. That is given that fx is equal to x if x belongs to this 0, 1 and is 0 for x equal to 1. So from here you can see that if f of 0 is, what should be the f of 1? Okay, I can solve it over here. Just let's check. So f of x is equal to 0 means at x equal to 1. This is the first thing. Next we have x belongs to this. This is a closed interval and the open interval. So closed means it doesn't include 0, but it includes 1. And the value at x equal to 1, it is 0. Okay. So what it is given for in the interval where x belongs to the set this closed of 0, 1, the fx is equal to x. So that is a continuous value. And at x equal to 1, this value, it is going to 0. So we can say that fx is continuous for the whole range except at f1. Right. So again we can find that for finite number of discontinuity, so here we have only one point of discontinuity, this particular function is Riemann integrable. But if we have this infinite number of discontinuity, then it should not be a Riemann integrable. So option D is also correct in our case, since it has only finite discontinuity. So this, out of the 4 options, 3 options are correct. So that's with this question number 35. So in the next lecture, thanks for watching.